As always, now that we understand what magnitude is, we need to add the magnitude operation to our vector. And before we actually do that, I want to write some tests for it. So test vector 3D magnitude, like so. And let's vector 3D our vector, and we'll give it components 3, 4, and 5. We did a 3, 4, 5 triangle before, but now remember our vector is a three-dimensional vector, and so I want to test this. I want to get all components to be something unique. And then I want to say float magnitude gets our vector. Please give me your magnitude. And then expect float equal magnitude to be, what value should it be? Let's get our calculator back up here. And let's see. 3 times 3 is 9, plus 4 times 4 is 16, plus 5 times 5 is 25, equals 50. Square root of 50 is this big ugly number. Edit, copy. Let's see how precise the compiler will let us go. I don't think it'll let us do that many digits, but I might be surprised. I've never tried. Magnitude is not a... okay, well, it's saying, hey, you're going to truncate this to a float, which isn't the end of the world, but let's just drop an F out here and see if the compiler will complain more. And there we go. So I guess that is a legitimate float that the compiler can handle. Now magnitude doesn't exist, so we'll go back to vector 3D, and I think magnitude syntactically would fit in right here. Float magnitude, it's a const function again. It's not going to change the contents of our object. And then where did I put that syntactically? Right below the dot, so we'll put that right there. Bring that back. Vector 3D magnitude const, and we'll return 0 just to make sure our tests fail. First of all, let's see if this builds and runs. Build started, and of course it compiled, but this engine tester is not set as our startup project. Where is that? Right there. Run it again. We should get some red. Red, red, red. Okay, value of this big ugly number, and this is the actual. We were expecting this, but we got 0. Anyway, let's implement this. So should be pretty straightforward. I can't remember if we have CMath included in our header file. We need CMath for the square root function. So I'm going to pound include CMath right here. Remember, we include the inline file right here, and so we're just making the square root function visible for our magnitude. Square root of x times x plus y times y plus z times z. That should solve the problem. Build that, run it. Let's see if the tests pass. And we're looking pretty green. Looking pretty green. I'm feeling pretty good about that. So there you go. We now have magnitude. We need to explore the dot products a little further before we're able to bounce the ship off the arbitrary edge. But we're getting there. We're getting there. Don't worry.